Hi guys, welcome back to 360DigiTMG's domain analytics program, guys. And I hope you guys are following from the very first day. If you're not, in that case, I will simply briefly go through it. What are the things that we have covered in the very first day? And the second day, it is the third day of domain analytics, that too in insurance and banking that we are covering. And yeah, if you haven't gone through it, so please go through it. And if not, I'll be going through briefly. So on very first day that we have discussed, so what is machine learning and AI? So how machine learning and AI will be used in banking and insurance domain. So basically we have discussed what are the applications of machine learning and AI when it comes to banking and insurance analytics, the whole various applications we have seen. And after that, crisp ML methodologies, crisp MLQ. In order to do project when it comes to data science, what are the hierarchy we are following? So what are the phases? In how many phases we will be doing the data science project? So what we will be doing in each and every phase. So we have 6 phases like we have seen in the previous session. So what we will be doing in very first phase and second phase, like we have seen, right? The very first phase is the business understanding. Business understanding. What we will be doing in business understanding? Based on the data, the problem statement provided by the client, we will be coming up with business objective. So what is business objective? What are the business constraints we will be having? So what is the economical success? What is the product that we are developing or the model that we are building? What is the success criteria of that? So these all comes under business understanding. And then, so what exactly supervised algorithm is? What is unsupervised algorithm is? So what is the difference between these? And when we are training the machine learning model using the unsupervised, in that case, how the training happens, how the output comes out, how we will be giving the inputs to the unsupervised model. When it comes to supervised model, how the data splitting is happened. So which data we will be using for the training and which data we will be using for testing. So all these things we have discussed in the previous session, and how we will be doing the evaluation of that particular model. So what happens when you have a classification and how we will be doing the evaluation? What happens when it comes to regression and when we will be going for the regression? These are all things we have discussed in the previous session. In today's session, we will be discussing about EDA, exploratory data analysis. So whatever once you have received the data and you know what exactly the project objective is, and then we will be collecting the data once the data collection is done. So whatever the data that we will be collecting, it is in the form of raw form. So when you have raw form of the data, various anomalies will be having. Anomalies means something wrong with the data. Anomalies means like duplicate data, the same entry we have done for multiple times, and missing values. So whatever the feature that we are considering, we may not be getting all the data in that particular feature. So that is a missing value, we'll be calling it as. Yeah, extreme values may be because of human error. While we are entering the data, maybe instead of 100, you might have entered 10 extra. Human error, so it might lead to the extreme value. And outliers will be having those extreme values when we are doing the analysis using the box plot. We'll be converting those extreme values into outliers. So these all comes under anomalies. So what is the extreme value? How we will be terminating those? All those things comes under pre-processing. Exploratory data analysis means, so whatever the data that we have, based on that, we will be doing some exploration, data exploration, so that we can find the insights. So that we will be calling it as exploratory data analysis. So today we will see what exactly the exploratory data analysis is, what are the, what kind of visualizations we will be doing, and how we will be doing the pre-processing. So all those things we will be seeing in the today class. We'll see the agenda. Exploratory data analysis first. We'll do some visualizations, what exactly those visualizations are. Business moments we'll be having, how can we analyze data based on using the various business moments, data pre-processing in insurance and banking analytics. So how, when you have a banking data or insurance data, any one of those we will be taking, and we'll try to do visualizations at the end, and we'll try to do pre-processing when it comes to banking data. So yeah, without wasting any time, let's jump into the session. Whenever you are receiving the data, since we have already discussed, so many anomalies will be having. First question you will be asking when you receive the data, what kind of data types you will be having? What kind of data types you will be having? So various data types will be having, right? Categorical data, discrete data. I mean, categorical data is part of the discrete data only. In that we have nominal data, whether we have a ratio data, whether it is qualitative or whether it is quantitative. So these kinds of questions will pop up whenever you see the data frame. So which data it belongs to? So when you have categorical data, what kind of pre-processing we have to go through? When you have a numerical data, what kind of pre-processing you have to go through? These things you will be asking right after getting that particular data frame. Exploratory data analysis refers to the critical process of performing initial investigation. What we are doing, we are investigating the data so that we can get the patterns out of those data. Data means Excel sheet. So much data we'll be having, but just by looking at the Excel sheet, you won't be able to find out the inferences, right? You have to do so much visualization, then only you'll come up with inferences or patterns, discovering patterns. To spot anomalies, to test hypothesis, and to check assumption with the help of summary statistics. We will be applying so many statistics on that particular data. And we will be doing the graphical representation. Those will be calling it as visualization, and then we will be coming up with the inferences. So that is only we will be calling it as exploration, data exploration. So normally exploration or EDA, exploratory data analysis, starts by asking me some basic questions of data sets to make initial assessment of the data structure. What exactly those are? Is there any existing unique record ID? So in order to count each and every customer, we will be having customer ID, right? Or product ID. Do we have any question, something, any feature, something like this? Are fields populated with the numbers, dates, or alphanumerical characters? So if it is only with numbers, and if it is having decimal, in that case we will be considering as continuous data. If you are having just numbers, it might be continuous or it might be discrete. Date, so we have separate data, and alphanumerical characters. That means you will be having numeric and you will be having the alphabets as well. So combinedly, we will be calling it as alphanumeric. We will be considering this as the categorical data only, but if it is not having any order, in that case, will come under nominal. If it is not providing any information and it is not following any order, in that case, we will simply considering as nominal data. And what kind of distribution we have? So if you have a numerical data or continuous data, what kind of distribution will we having? Whether it is balanced distribution or normal distribution, will also called as the normal distribution. How many values exist for the categorical fields? When you have a categorical fields, that is what? Textual fields. How many unique values you have in the textual fields? And the textual field is for output data we'll be having or input data. If it is for input data, it will be doing the encoding techniques and all. If it is output data, and how many unique values will be having? Based on those unique values, we will be considering as classes. How many fields have been left blank? How many missing values will be having? How are multiple data sets related? Whatever the data that we will be having, is it having any correlation in between the input columns or not? So these are all questions we will be asking right after receiving the data. When you ask this question, in that case, you will be working on those particular data, whether it is numerical, when in that case, we will be going with whether it is balanced data or not, if it is output categorical in that case, whether it is balanced or not. So all these kind of questions we will be asking whenever you're receiving the data. Exploratory data analysis. Once you know those all features, and if you have done some pre-processing, in that case, we will be doing this exploratory data analysis. In exploratory data analysis exploratory data analysis means visualizations only. We will be doing the various visualizations. See, normally when you have Excel data, you won't be able to understand anything. But let's say two branches will be having. You are doing some business, you have stores, that is store A and store B. I want to compare both profits and sales, which product are getting sold more when it comes to store A and store B. So if you want to go through these information and you have only Excel data, Excel means numerical data you will be having. In that case, can you able to compare? No. If you have visualizations, in that case, we can easily able to compare where exactly you are getting the most sales, most profits where you are getting, and among those, whatever the products will be having, which products are getting sold more among the top trending products, what we have, all those things, and all those things when you come to know, when you do the visualizations. When you do the visualization, then only you will come to know. That is the reason we will be going with visualizations. Among those, we have various visualizations. Among these, one univariate. Univariate means you will be taking just one feature and then you will be creating the visualization. So what are the examples? Univariate, name itself saying just one variable I am taking. Variable means input or output. Just one variable I am taking and then I'll be creating the visualization. So what are the examples we will be having for that? Bar plot. Bar plot is univariate, and we have histogram. Just based on one feature, whether it is salary, age, something like the numerical will be having it. For numerical only we will be able to do the histogram. So it is also univariate. And then we have box plot. When you have a numerical data that is continuous or just numerical, if you want to know what kind of, do we have any extreme, or especially when it comes to box plot, outliers. Do we have an outliers in our data or not? In order to know this, we will be going with box plot. It is also univariate. Just one variable I am giving to find out the outliers in our data. How we will be doing the outliers, we will be seeing in the end. Bivariate analysis. Here in univariate, in that case, just one. Bivariate means we will be having two variables. Two variables. We will be having two variables. So in order to find out the correlation, how two variables are related, numerics or continuous variable, how they are related. To find out that, we will be having scatter plot. To find out that, we will be having scatter plot. In that, one variable will be taking an x-axis and one more variable we are taking the y-axis, and then we will be doing the we will be finding out the relation between those, how correlated those are. And then we will be having multivariate. So univariate 1, bivariate 2, and when it comes to multivariate, we have more than 2. If you have more than 2 variables and you want to do the analysis on that, in that case, we will be calling it as multivariate analysis. Multiple variables. So mostly we'll be using pair plot. So all the variables, whatever the variables will be having, you can use all at once and you can find out the correlation among those. Pair plot and heat map are the examples when it comes to multivariate analysis. When you have more than, when you are using the more than 2 variables in order to find out the relation or in order to do some histogram plots. So normally when you go with a pair plot, what you will be having both histogram as well as correlation you will be having. That's kind of mixed up histogram plus scatter plot. In diagonal, we'll be getting all the same, whatever the features will be having, their histogram you will be getting, and then you will be getting the scatter plot. So it is a pair plot, and then we will be having heat maps, how 2 variables are related. For that, we will be having the heat maps. So these are EDA and the graphical analysis. So what are the graphical analysis will be having? Univariate, bivariate, and the multivariate. And then we'll be having in exploratory data analysis only statistical analysis. And then we have first moment business decision, and then second moment and third moment and fourth moment. What exactly the first moment business decision is? Whenever you're talking about the business, very first question everyone will be asking, what is the average sales or average profit that you are getting per month or quarter or per year? So these are the questions we'll be asking, right? So it is a first moment business decision. So what exactly we will be having in first moment business decision? We'll be having mean, median, and mode. So whatever the data that you'll be having, first we will be finding out the mean, median, and mode. So this we will be calling it as first moment business decision. What is the mean of that data? And what is the median of data? When we will be going with mean, when we will be going with median, that we will be discussing. So normally, when you have an extreme values in your data, extreme values if you have, or the outliers if you have, in that case, we will be going with median because it won't affect our analysis. But when you don't have the outliers, in that case, we will be going with mean. So mean will be affected when you have extreme values. That is the reason we are going with the median when you have outliers, and mean when you don't have outliers. And then we will be having second moment business decision. So it is a measure of dispersion. So how far, let's say I've taken the age, various ages have taken 25 years to 72 years ages have taken. If I calculate the mean of these, let's say I've got 35 as a mean. So mean, whatever the data, actual data we will be having, how far these from the mean? How far these from the mean? To that we will be calling it as the spread. We will be calling it as dispersion. How far? Or we can also call it as variance. So variance and standard deviation and range. Range will be calling it as from where to where? 25 to 22 to 72 we have said, right? So this is the range, minimum value, and what is the maximum value. The difference between the minimum value and maximum value we will be calling it as range. So whatever the difference will be having, actual value and Actual value minus mean. That difference, if you are squaring, in that case, we'll be having variance. If you do square root of those variance, in that case, we'll be getting the standard deviation. So these all calls about dispersion, measure of dispersion. That is the reason we'll be calling it as measure of dispersion. How far the data point is from the mean. And then we'll be having third moment business decision, in that whether the data, whatever the data we will be having, either whether it is symmetrical or not. If it is symmetrical, so we will be calling it as normal distribution. So the third moment business decision is talks about whether data is symmetrical or not. If it is symmetrical, in that case, we'll be calling it as normal distribution. If it is not, in that case, we will be calling it as skewed data. If you have most of the data is on the left side and the right side, if you have a tail, in that case, we will be calling it as right skewed. If the most of the data are on the right side, on the left side, in that case, we will be calling it as left skewed. In that case, we will be calling it as left skewed. And then we will be having kurtosis at the fourth moment business decision. It will talk about the peakedness of the data, which are the product most number of times getting sold, and tailness of the data, peakedness and thickness and thick and thinness of the data. It will be talking about which are the products more number of times, more frequently getting sold, which are the products not getting sold much. So it is will be called as kurtosis. So these are the 4 business moment decisions. So how these will be useful? So when you are exploring the data, in that case, you can use any one of these, all of these to find out the inferences from the data. What is the mean? What is the average? And whether it is, how much dispersion will be having, how much information that data is having, and whether it is symmetric data or not. If it is not, in that case, we will be making it symmetric by doing the transformation. And peakedness of the data, which are the products are most number of times getting sold. This kind of information you are able to infer when you apply this statistical analysis on that particular data. So we have pre-processing, and then we have pre-processing. In pre-processing, these are the various anomalies we'll be having, and how can we overcome those anomalies. That is also we will be discussing. So very first anomaly, that is typecasting. So normally, whatever the data, based on the data, Python is capable of finding which data type it belongs to. Let's say salary. Salary will be having 35,000, 45,000, 50,000, something like that. Will be having. It is a non-decimal form. It is not in the form of decimal. But I want to represent the salary in the decimal form. So previously we don't have any decimal form, but I want to represent it in the decimal form. In that case, we can use typecasting. Typecasting means converting one data type to another. Converting the one data type to another. In that case, we'll be calling it as typecasting. And then we'll be having duplicates. The same data, duplicates itself, copy same data. If we have a same data one more time in our data frame, in that case, we will be calling it as duplicate. Let's say X, Y, Z. So these are the features I'll be taking. So 157, 257, this is the data I have. 5, 7, 8, this is one more data. Again, I have 257. So whatever the features I am considering, the same data I have here and the same data I have here. So in that case, I'll be calling this as duplicate. This as duplicate. Same data, same information you are giving again and again, right? So this we will be considering as duplicate. This duplicate won't be giving any extra information for us. So what we will do, we'll simply drop those duplicates. Drop function will be having drop duplicated. So in that case, it will simply drop whatever the features are repeated, whatever the information that is repeated, will simply dropping it. And then we will be having outlier analysis and treatment. So we have 3R techniques, triple R techniques: rectify, retain, remove. Rectify, retain, remove. First, what we will be doing, whether whatever the data that we will be having, whether it is outlier or not. So we'll be checking that. Outlier means what? If the data is completely different with whatever the data we will be having. Let's say age column I'm taking. In that column, I have 25, 35, 33, 35, 70, 78, 90, and I have 150. And I have 150. Do you think it is actual value? Do you think, do we have, I mean, people will be living up to 150? 150 years of age. Maybe while he is entering, the person whoever entering. So instead of 15 years, he might have put one extra. So it is one of the anomaly. So we will be rectifying that, whether it is possible or genuine case or not. If it is not, in that case, we'll simply remove it. But if it is genuine case, in that case, we'll retain into the data frames. We'll keep it as it is. But if it is not, simply remove it. Rectify it is very different from the main data. And retain if it is genuine. If it is not, in that case, we'll simply remove it. So this we will be calling it as triple R technique. Triple R. So zero and non-zero variance will be happening. So just now we have seen the spread of the data, variance. How far? Let's say it is a mean. It is a mean. How far the data is spread? How far data is spread from the mean? If there is no spread in the data, let's say if I take age column, in that age column, all are 32. All are 32. When I find out the mean of these values, in that case, so how much I will be getting? 32. And if I find out the variance, it is 32 and all are 32s only. All the data points are on the line. So you won't be having any variance. No variance or zero variance. When you have a zero variance, the data won't be having any information. When you don't have any information, in that case, it won't be help you out to find out any predictions or to predict anything. So in that case, we will simply drop those zero variance cases. Non-zero variance cases, let's say you have 100 entries. Among us, 95 entries will be having only 32. Just 5 entries will be having something different, 55, 60, 70, something like that. Even it is won't give you much inferences. So what will be doing? Will be dropping both zero variance and non-zero variance. Will simply drop both the features. And then we will be having discretization. So when we will be doing the discretizations, whatever the continuous data will be having. When you have continuous data, to convert that continuous data into categorical form. Categorical means, let's say I have a salary column and the salaries are in the range of the various ranges I'll be having, like 15,000 and 25,000 and 25 paise, something like that, and 50,000. The various salary ranges will be having. I want to convert these various salaries into two categories: high salary or low salary. So whatever the data, whatever the salaries that are above 25,000, I'll be considering as high salary, and below the 25,000, I'll be considering as low salary. So if I convert this continuous data into categorical, so what we are doing, whatever the continuous data will be having, we are simply converting into categorical. That we will be calling as discretization. Here 15,000. So it will be under 25,000, right? So it is converted as low. 25,000, so it is, so we can say greater than or equal to. In that case, I'll be considering as a high. Like that, 50,000, it will be considered as a high. So whatever the continuous data I'll be having, I'm simply converting into discrete or categorical. In that case, I'll be calling it as discretization. So this will be call it as whatever the continuous data I will be having, I am converting that continuous data into discrete values or categorical values. That we will be calling it as discretization. And then we will be having missing values. In that missing values, we have various missing at random, missing completely at random, missing not at random. So various missing values will be having. Whenever you have missing values, various techniques also will be having. One of those, I mean, very famous techniques are two will be having: trimming, winsorization. So these are the two very frequently used techniques we'll be having. Among these, winsorization is used more, I mean, more frequently. So what happens in trimming? If you find this for outliers. So we'll be having the outliers analysis. We'll be doing the finding out the triple R technique: rectify, retain, and remove. So in that remove, rectify, remove, these are the ways we can do it. Otherwise, we'll be having these techniques: trimming and winsorization. What we'll be having when it comes to trimming and winsorization? In trimming, whatever the outliers will be having, we are simply removing it. So that we will be calling it as trimming. And then we will be having winsorization, whatever the outliers will be having. We will be replacing with upper cutoff value and lower cutoff value. Upper cutoff value and lower cutoff value. That we will be calling it as outlier detection techniques or outlier removing techniques, trimming and winsorization. It is for outliers. And then we'll be having missing values. Various missing values will be having, like we have seen, missing completely at random, missing at random, and missing not at random. So when you have these, we have very techniques, various techniques will be having in order to impute those missing values. Among these, very first one was mean imputation. When you have numerical data, we'll be having mean imputation. What is the mean imputation? Whatever the numerical data will be having, we'll simply calculate the mean of those, and wherever there is a missing value, we'll simply replace. And then we have median. So wherever you have a numerical values, and if it is having the outlier or extreme value, so we'll simply replace, we'll be finding out the median, and then we'll be replacing with median. And then we have mode. If you have a categorical data, this mean and median for numerical data, and if you have categorical data, in that case, we will be imputing using the mode. So it is, these are the missing value imputations. And then we have dummy variable creations. In dummy variable creation, what we will be doing, so whatever the categorical data will be having, you can't, 90%, maximum algorithms won't take categorical data directly. So what we have to do? We have to convert these categorical data into numerical. For that, we will be having various encoding techniques. Among these, dummy variables and one-hand encoding and label encoding and ordinal encoding. Like that, we have various encoding techniques. Like that, we will be having various encoding techniques. Why we are using this? Whatever the categorical data that we will be having, we are simply converting into numerical. So that we will be calling it as dummy variable creations. And then we have transformation. So when you have unbalanced data in the sense when you don't have a normal distribution, let's say you have right skewness. When you have right skewness, in that case, we won't be using the data as it is. Instead, we will be converting this non-normal distribution, non-normal data to normal. That we will be calling it as transformation. Converting non-normal distribution to normal distribution, we will be calling it as transformation. We will be converting one form of the data to another, just to so that we can apply all the statistical techniques on that particular data. So that we'll be calling it as transformation, and then we'll be having standardization. When you have data, let's say these are the features I have taken, X, Y, and Z. So here data will be having like 10, 15, 20, 13, 25, something like that will be having. Here 0.1, 0.7, 0.5, and 0.8, something like that we have. And here we'll be having 10,000, 15,000, 7,000, 5,000. So whenever you are building the model with these features, definitely whatever the features having the high value will definitely impact our model, right? So it will be having bias, since value is much more compared to these. So what we will be doing to avoid that biasness in our model or the output or the in prediction, so we'll be converting all these into one scale. Various scales will be having, right? Various scale will be having. We are simply converting into unit scale. Just one scale, or making the data unit free. That we will be calling it as standardization. So in this we'll be having normalizations as well, normalization and standardization. In normalization, what we will be doing, all the data, whatever the data will be having, we are simply converting in between 0 to 1. And in standardization, we'll be converting -3.4 to +3.4. So what it is called? Standardization and normalization. And here we'll be having one more property, mean is equal to 0, standard deviation is equal to 1. So that whatever the numbers that we are converting into standardization, they will be having this property, mean is equal to 0 and standard deviation is equal to 1. And then we'll be having string manipulations. When you have textual data, so textual data will be having a sequence. So in that case, we will be dealing that string very differently using for string manipulation. We'll be discussing in a minute. So it is having the sequence, and we can't do the same pre-processing like we are doing for the numerical data here. So we have separate pre-processing when it comes to string data. How we will be doing that, we will see now. String data. So slicing we will be having which data I have to take. For that we will be having indexing will be since it is a textual data, it will be having sequence. When it is having sequence, we can access the data using the index. So how, and there are so many operations that we can do. How we can do, we'll see now. So whatever the operation that we have seen till now, these are all for numerical data. But when it comes to textual data, we will be having very different. For that, we have various libraries, something like BERT, SPACY, NLTK, or NLP. So NLP techniques will be calling it as natural language processing. So when I have a textual data, how can we do the pre-processing? Since it is a not numerical data, we won't be applying the same pre-processing technique that we have discussed till now. We will be having very different pre-processing techniques. Among these, tokenization, normalization, and the noise removal will be having. So what exactly the tokenization is? So whatever the sentence we will be having, breaking those sentence into different words. Let's say here various processes are. So it is one word, it is one word, it is one. So combinedly, it is will be calling it as sentence. So all the whatever the sentence will be having, we are simply breaking into words. Wherever there is a space, we'll simply split it. In that case, we will be calling it as tokenization. And if you have any noise removal, when we will be doing noise removal, when you are extracting the information from the website, so there are so many anomalies will be having, like tags, numerical numbers will be having. So various numbers will be attached to the text. So what we will be doing, we'll simply pre-process. Here also we'll be doing the pre-processing, but that is completely different when it comes to numerical pre-processing. In order to remove the noise. Noise means the data which is not necessary, that will be called as noise. So we'll simply getting rid of those numbers. And if you have an extra tags and special characters will be having, let's say ashtray and ash and dollar sign, question mark, all these comes under special characters at the rate. So we will be removing all those things since we won't be able to pre-process those data. So what are the anomalies we will be having? Based on the general when you are extracting the information, HTML tags will be having, white spaces means empty spaces will be having, that is also comes under. Convert accented characters into ASCII, ASCII characters. So some characters will be having meaning. So we will be converting into this format. Expand contractions. So if we have any brief words like shortcut words, in that case we'll be expanding those. Remove special characters at the rate, dollar, question mark. This all comes under special characters, and lowercase all the text. So why we are doing the lowercase? So NLP text mining, while we are doing the text mining, what happens? Let's say apple. So let's say this is one word, and if you are using small apple, in that case also it is very different word. This is one word and this is one more word. And if you are using a capital P, PLE, in that case also it is a different word. Python, it will consider all of the different words. So here we have 4 words, but normally are these 4 words? All considered as not apple only. So capital and small, if you are using very, very differently, in that case, Python will be considering as very different. So what we have to do, if you convert all these into lowercase, in that case, what happens? Apple, it is also apple and it is also apple. Now Python will be considering all are just one, that is apple. So for that, we will be converting all these data into lowercase. And then we will be using bag of words to convert all the new, all the words that we'll be having into a numerical form. And if you have extra numerical values, that numerical data in the text, in that case, we'll be removing that and removing the stop words. So let's say if you are doing with, if we are going with the sentiment analysis, in that case, do we need words that are not expressing or having any sentiment? Let's say I'm going for sentiment analysis, and in that I have a sentence something like this: I like apple. Or do you like apple? Let's say these are the 2 sentences I'll be having. So which are the sentences that are having sentiment? So other than which are not representing any sentiment. So what we will be doing, we'll simply make it, or we will be removing this data using what? Stop words. So stopword list will be having, or you can create one custom stopword list you can create based on the requirement you will be having. So here, like it is representing some sentiment, apple. So I'll be talking about the apple. So you do like apple. So these comes under stopwords because very frequently we are using. But is it representing any sentiment here? No, it is not representing any sentiment. So what I will be doing? I'll simply remove all these things. Whatever the data that is not having any sentiment. So in that case, I'll simply removing those data. So that we will be calling it as stopwords, removing the stopwords. These are all stopwords. We can create one stopword list and you can apply that filter. So in that case, what happens? Whatever the stopwords we will be having in our data will be removed automatically. Will be removed. So these are will be called as stopwords, which doesn't have any sentiments. Mostly these are nouns and adverbs. Like these words doesn't represent any sentiment, so we will simply remove those. And then we'll be having limitation. So what exactly the limitation is? Let's say if you have one word, let's say singing. So if you want to convert that data, whatever the word will be having into the base form. In that case, we will be using lemmatization. Whatever the data or whatever the word that we will be having, if you want to convert that word into the base form, in that case, we will be using the lemmatization. So what happens in lemmatization? Whatever the extension will be having here, singing. So what is the extension will be having, whether it is prefix or whether it is suffix? What extension will be having? Singing. So it will simply remove, and once it is removed that extension, it will check whether this data, that is word sing, is present in the dictionary or not. If it is present in the dictionary or not. If the data, whatever the word that we have removed, and the base word, if it is present in the dictionary, in that case, it will take it as it is. It will simply take it as sing. But if it is not present in the dictionary, in that case, whatever the nearby word will be having, it will simply replace with that particular word. So that we will be calling it as lemmatization. So these are the pre-processing techniques we'll be having. So various pre-processing techniques for the numerical data, when you have a numerical data, and when you have a categorical data. When you have a categorical data, and how we will be doing the pre-processing. When you have a categorical data, how we will be doing the pre-processing that we have seen. So now we will try to understand how we will be doing the visualizations. So whatever the theoretical concept that we have seen till now, we'll try to do this exploratory data analysis, or you can say pre-processing when it comes to banking data. Since we are discussing about the banking rate, so we'll see how it will be done. Okay. So I've already imported the data, that is credit test. So in fact, what are the features we'll be having? We'll see. In order to do the pre-processing, you can do using the same thing you can do using the notebook, Spider, or you can do using the Google Colab as well. So for now, I'll be using the Google Colab. So I have already imported the data, that is credit test So what are the features we will be having in our data? We'll see. And before that, in order to import that data, so we need to have some libraries. What are the necessary libraries we'll be having? I'll be importing that. First, we'll be having pandas. Pandas is responsible for all the manipulations. Pandas is responsible for all the manipulation that we will be doing. So manipulation in the sense, if you want to change name of feature, or if you want to import the data, or if you want to find out if we have any anomalies. So all the changes and all the changes that you want to do on the data frame will be possible using the pandas. Even importing the data, we need to have pandas. And then we'll be having NumPy in order to do the mathematical calculations. In order to do mathematical calculations, I need to have the NumPy library. So I'm importing that NumPy library as well. And then we will be having matplotlib. So all the visualizations that we will be doing, visualizations. For that, I need to have a library called matplotlib. And then we have SNS plot as well. SNS Seaborn package also will be having. If you want to do some advanced visualizations, for that I'll be using the SNS. So let's import the data and we'll see how we can do the visualizations. So I'm simply running this data. First, I'm importing it. So now it is importing the required data for the descriptive analytics. So in order to do the analysis, I'm importing. Pandas have imported, and the imported NumPy and as well as matplotlib. So once it is imported, I'm giving the address of data frame, where exactly I have a data frame that is in the form of CSV. So what I'm doing, I'm simply creating one memory variable, and in that using the pandas, you can see here, pandas, I'm reading that CSV file, whatever the CSV file I'll be having, from where this is the location I have given, and whatever the data that I have in this credit.test, I'm simply saving into data frame D. So in this memory pointer, all the data that I'll be having, it will be stored. So run it. So it has been stored in our data frame. In order to see what kind of data we have, so I'll be using the function head. I'll be using function head. What exactly the head function do? It will simply show you the first 5 data or entries. So you can see first 5 samples, or you can say entries of the data it will be showing. See here, years in the current job, how many years, from how many years you will be having, you will be there in that particular current job. So 10 plus years, 10 plus years, 2 years, 10 plus years. So it's the first 5 entries it will be showing. So first we'll understand what kind of data it is, what exactly the data is about. So what exactly the data is about? First, we have loan ID. So people will be applied for the loan, right? Various people apply for the loan. Bank data IDs. So when you are applying the data, you have to give so much information. What do you have in a job or not? If you are having job, what kind of job you will be having? From how long you will be working in that particular job? And how much is the salary you are having? And do you have any outstanding loans or not? So what is the purpose of your loan? What you are trying to do with that particular loan? So all these details they will be asked. Right? Banking people, they don't give you the data, I mean the loan that easily. So you will be having all this. So that is the data I will be having here. Loan ID. So whoever the person who applied, so for that that person will be giving one loan ID. And then customer. What is the customer ID? That is a customer ID. And then we will be having current loan amount. So how much loan he has already. Terms, whether it is for short term or long term. And then we'll be having credit score. How much credit score you'll be having in order to give you, a loan. They will be looking at the credit score, right? Annual income. How much package will be having? From how long you will be working in this particular current job? whether the home that you will be having, whether it is your own home or rented. Purpose, why we are taking that particular loan. Monthly debt, how much, whatever the salary that you are getting, how much you are, giving for the debt only, whatever the loans that you have taken previously. Years of credit history, how much credit history will be having. So months since last development. So various we will be having. You don't need to understand what exactly the feature is about. We'll be doing the visualizations and pre-processing. So it is head function. It will be giving you all details. So I'm simply checking the info. So if I check the infos, in that case, what kind of details it will reveal? What are the features we'll be having? What are the features we'll be having? What kind of data set, or whether we have any null values or not. So seems like we have 10,000 data. Since in this also we have 10,000 data, here also we have 10,000 data, mixed entries. Here also we have 10,000 entries. Here we have just 8,000 entries. That means credit score is missing for rest people. Total we have 10,000. Among those, 8,000 entries only will be having it, and the rest we don't have any data, right? So that we will be considering as missing values. That will be considering as missing values. Here, annual income. So here also we have so many missing values. Here in current job. So here also we have missing values, and their home ownership, we don't have any missing values. Purpose, no missing values. Monthly debt, no missing values will be having. So these are total values we have. How many entries? 10,000 entries will be having. Among that, how many missing values will be having? So that data is present here. So whenever you are using the function dot info, in that case, it will be giving you all these details. It will be giving you all these details. So you will be able to understand like where exactly we will be having the missing values more. If it is having more than 35% of the missing values, whether you should keep that particular feature or not. Most number of data is missing values only. In that case, you can't do all the imputation techniques on that particular, right? You can't do all the data. Let's say 10,000 data you'll be having. In that, only 1,000 data information only available, and the rest data, it is not. You won't be able to do missing value imputation for all, right? So what you will be doing? You will be removing that particular feature. So you will be getting an idea which one we have to keep, which one we should remove. Something like that we'll be getting using the data info. So in describe. So describe function will be having what exactly we'll be doing the describe function. That transpose, it is a transpose. Let's say here these are the features, and in order to see all these features, we have to scroll it. Instead of that, we can simply use transpose so that I can check all the features here itself. Credit, current loan, amount, credit score. Describe means it will be giving you information regarding the count, how many number of counts will be having, what is the mean value of those data, and what is the standard deviation. Among these, what is the minimum value and what is the maximum value, how much data is present, less than 25 percentile, less than 50 percentile, less than 75 percentile. So this will be collected as quantile. It will be helpful to find out the outliers in your data. So these are the features and their respected mean, median, mode. So if you see minimum value and the maximum value, so we are having the huge difference in the range. So here, what is the minimum value? Minimum value itself, how much it is? 19,000. And we have over crores of rupees. Here you can see just credit score 585, and the maximum value will be having so much. Annual income 81,000 is the minimum value, and the maximum value will be having so much. And here we'll be having 1. So we have whatever the range will be having. If it is similar range, in that case we'll be keeping as it is. If the range is very different will be having when it comes to each and every feature, in that case we will be going with normalization and standardization will be having, right? Any one of those you can go through. So you can, based on the minimum value and maximum value, the range is very different. In that case, we can easily able to do we can go with the normalization or standardization. Both we will be using any one of those. It is fine. You can go with that. So what are the unique values we'll be having in that particular data? So let's say in term, what we have in terms, you can see how many number of terms we'll be having. What kind of loan you want, whether it is short term or whether it is long term. So these are all concerned about what? Data analysis, exploratory data analysis. How many we have short term loans? How many people are claiming for asking for the short term loans? How many people are asking for the long term loan? So how many we have short term and long term, and we have NaN values. So NaN means missing values. We don't know whether they are asking for the long term or short term. How many of them? You can easily able to understand. Among those 10,000, how many people are asking for the short term? How many people are having asking for the long term? That is also will be useful for the analysis. So we can take that values as well. And how many of them are having the null values? So is Na, whether you have any Na values or not? If you have, how much Na values will be having in that particular data? For that, I can simply run here the same. I have already run it. So you'll be getting the same information. Term unique. And how many number of unique values, NA values, missing values will be having in data. So loan ID. So anyway, loan ID will be a nominal data and customer ID will be a nominal data. Whether it is having any missing values or not, anyway, will be not considering that data. So let it be. But here we'll be having 353 missing values when it comes to current loan amount. Term, 353 missing values will be having. Credit score, how many number of missing values will be having? How many we have? 2,334. You can see here the same thing. When you are finding out the info, when you are finding out the info, in that case also we'll be finding, right, non-null values. How many non-null values will be having? 10,000 non-null values. Means overall 10,000 data entries only will be having. These are having some null values. Non-null values 8,000 means rest. Minus 10,000 minus 8,019. If you do, you will be getting that. How many missing values will be having? The same data will be getting here. 2,334 NA values will be having in this data. In this annual income also will be having that much missing values. And then I want to do the visualizations. Visualization for what data that you want to do. So we can mention that particular data and you can go with the visualizations. Here you can see loan ID, how much data is present, customer ID, how much, and term, credit score, annual incomes, all the data. If you want to do the visualization, you can simply go with matplotlib and you can create a visualization. And here years of credit history. So whatever the data. So here we'll be having what exactly it is, histogram. So histogram comes under univariate plot. So we will be using just one univariate. Any one feature we are using in order to create the visualization. So here what features I'm taking? Years of credit history. So and I'm using the bin size is equal to 20. That means the space will be having it 20 it will be taking, and then it will be creating the visualization. So what exactly this is? We'll be finding out whether this data is symmetrical or not. Is it symmetrical? It seems like a slightly skewed towards right. Slightly skewed towards right. So it is a right skew data. When you do the visualization, then only you will come to know whether it is normal distribution will be having or non-normal distribution will be having. If it is normal distribution, in that case we'll keep it as it is. If it is not, in that case we will be doing a transformation. So for this, transformation is required. Since it is a not symmetrical, it is not symmetrical data, it is non-symmetry. So we need to do transformation for this data. It is a univariate plot. And then I'll be creating one more credit score of that particular person. So you can see here, most number of people's credit score are in between 0 to, or you can say in between less than 1000 only. Very, maximum people among 10,000 people. Among 10,000 people, right? Overall non-null values will be having 10,000. Among those, over 7,000 plus people are having credit score over in between 500 to 1000, you can say. And very less people, like barely 200, 300 people will be having credit score in between 6,500 to 7,000 or 7,500. So these kind of inferences you will be getting when you are doing the visualization. Here also, it is a histogram. That means univariate. So what is the variable we are taking here? Credit score. How the credit score is spreaded. To know that, we are going with the histogram. And then we can do with individual, the outlier analysis as well, or you can combinedly do the outlier analysis. Here, what I am taking, wherever numerical values will be having, wherever numerical values, box plot can be drawn for the numerical values only, right? What exactly we are doing with the box plot? We have discussed the univariate plot. It is also concerned a univariate plot to find out whether we have an outliers or not. Whether we have an outliers in our data frame or not. So for that, we will be using the box plot. So here also I am using the box plot to find out whether we have any outliers in our data or not. So in order to find out the outliers in our data, box plot, what it will do, it will create one upper cutoff value and lower cutoff value. So we have seen, right, that is 25 percentile when you are doing the description of data, 25 percentile, 50 percentile, and 75 percentile. 25 percentile will be calling it as quantile 1, 2, and 3. Quantile 1, quantile 2, quantile 3. So it is the data, if it is 25%, under the 25% range, percentile, it is not percentage, percentile, and 50 percentile range and the 75 percentile range. Based on these values, we will be creating upper cutoff range and the lower cutoff range. So what is the upper cutoff range? Q3 plus 1.5 into IQR. So here we'll be calling it as interquartile range. Interquartile range. That will be Q3 minus Q1. So if the values are beyond this particular range, beyond this upper cutoff range, that we will be considering as outlier. Or outliers are on the both sides, it is not just one side. If the data that is beyond Q1 minus 1.5 into IQR. So Q3 here, 75 percentile of the data, Q1 is here 25 percentile of the data. If the data is beyond this is the lower cutoff and this is the upper cutoff. If the data is beyond this, in that case also I'll be considering as outlier. In that case also I'll be considering as outlier. If the data beyond the upper cutoff range and beyond the lower cutoff range, both we are considering as an outlier. So that is what box plot do. It will define those upper cutoff range and lower cutoff range using the quartiles. So quartile 1, quartile 2, and quartile 3. And based on that, it will simply categorize into which are the outliers data and which are the non-outliers data. So you can see here what I am doing, each and every data, whatever the data I'll be having. So whatever the features I'll be having that are numerical. So among these, how many data will be having numerical? So when you are doing the description as well, you will be getting the only numerical data description only. So loan amount, how much loan amount will be having, credit score, annual income, monthly debt, years of credit history, months since last delinquent, number of open accounts will be having, a number of credit problems will be having. So these are all numerical data only. So for that only, I'll be applying the box plot. So number of open accounts, current loan amount, monthly debt. So individually I'm applying. You can do all at once as well, but I'm doing the individual. Number of accounts, for that I'm applying the box plot. Current loan amount, for that I'm applying the box plot. Monthly debt, for that also I'm applying the box plot. Years of credit history, something like that, months since last delinquent, number of credit problems, current credit balance, maximum open credit, bankruptcies, whether he has done previously or not, tax length. So these are the features I am applying the box plot. When you see box plot, the very first one, the number of open accounts, you can see there are so many outliers. You'll be having so many outliers. So in this, we have outliers as well. In the third, whatever the box plot that we have done. So what is this? Monthly debt. Almost all the data having here will be having outliers, but very less outliers will be having. And here also we have outliers. All the data will be having in that. All will be having outliers. When you have an outliers, we have seen, right, two techniques will be having. Whether you should go trim, wherever you will be having outliers in the sense extreme. Whatever the data that we will be having, and these data are not similar, very different values will be having. In that case, we can remove it completely, or just now we have discussed, right, upper cutoff range and lower cutoff range. That is Q3 plus 1.5 into IQR and Q1 minus 1.5 into IQR. So you can replace with these values. Let's say if you have an outliers upper cutoff range. So beyond the upper cutoff range, you will be having outliers. What you will be doing? We'll simply replace with these values. If it is beyond the lower cutoff, in that case, we'll simply replace with this value. So that is we will be doing in comes to Winsorization. But removing the whole outliers, if you have outliers, simply trim out or remove it. That we will be using using the trimming. So these are the two techniques we'll be having to remove those outliers. So here we have found the outliers. Now we have to remove it. Since I'm not taking the exact data, so it is not necessary for now. But this is how we will be creating the visualizations. This is how we'll be creating the visualizations. And you can see here whether it is data is balanced or not. How can we say that it is balanced or not? So here, like that, if you want to create for the same thing for others as well, you can create. Let me create one more. Same, Control C, you can create one code, paste it here. And which data if you want to take? Annual income. So we'll take annual income. Whether it is data symmetrical or not, to check. Paste it. And run it. You will be getting whether it is symmetrical data or not. Is it symmetrical, guys? No, annual income is not symmetrical. So it is a most data present here only, and it is right skewed. It is not symmetrical. Symmetrical, when we call it as symmetrical, both sides on the left side, if you divide the whole distribution in the two, left side and right side, area is equal. Both left side and right side area, the area it is covered, it is equal. In that case, we'll be calling it as symmetrical, but it is not symmetrical. It is a right skewed one. It is a right skewed one. Something similar to that we can do for others as well. Let's do one more. Find out whether this data is symmetrical or not. So only for numerical data only we'll be able to do it. So we'll create one more. So we'll be taking maximum open credit. Monthly debt. How much monthly debt we will be having? That each individual is having. Whether it is symmetrical or not. And you can run it. Okay, sorry. Don't waste time on that. Simply take as it is. For what we are doing, monthly debt. It is not removing. Monthly debt. If it is symmetrical or also you can check it. See here, it is not symmetrical as well. So it is also right skew. It is also a right skew data. When you have right skew data, in that case, it is need to be, you have to do the transformation to convert this non-normal distribution into the normal distribution. So when you have a normal distribution, then only we can able to take into the data frames. Then only we can go with the model building. But when you have, why we are converting this non-normal distribution to normal distribution? Because by default, whatever the algorithm that we are taking from old days, so whatever the data will be having, by default we are considering or assuming the data as a normal. But here the data is not normal, and whatever the statistics that we are applying on the non-normal distribution, it won't give you a good result. That is the reason whatever the non-normal data we will be having, we should convert into the normal data. And what else we can do? Univariate analysis we have done, and we can do the scatter plot as well if we have a requirement. So what are the features we'll be having in order to find out the correlation or relation between the credit score and annual income. Is it any relationship we'll be having? In that case, we can do that as well. So like that, we can do visualizations and we can come up with the inferences. Box plot we'll be using for to find out the outliers in our data, and the histograms we'll be having in order to find out the symmetric, whether data is symmetrical or having symmetrical or not. Like that, we can do exploratory data analysis. It is not just for the banking data, guys. Whatever the data we'll be having, whether it is agriculture data or whether it is HR analytics, HR data, or whether it is healthcare data, any data, we will be doing the same pre-processing. So whatever the missing values we will be having, in order in that case, we will be doing the imputation. If we have a non-normal data, we will be converting to normal distribution. If you have a duplicate data, in that case, we will simply remove those duplicates from the data But when it comes to healthcare, we should be extra careful that whatever the data, missing data will be having. You can't do a random imputation. Let's say if you are doing the prediction of whether that particular person having the cancer or not, prediction of cancer. And in that we have features saying that whether you have a TB or not, whether you have undergone surgery or not. So which stage previously, whether you have habits of alcohol or not, alcoholic or not, something like that. We have various features. Based on that, we are predicting whether that particular person has a cancer or not. Not these features, we have various other features always. Features also will be having. So when you have these data and somewhere you have missing value, that is any. So in that case, you can't directly do the random imputation saying that here we have any missing values and the person has having TB or not. So here has is most number of times what we'll be doing here, we'll be calculating the mode. So which is most frequently occurred. So whether it is yes, TB, yes or no. So whichever the most frequently occurred, let's say it is yes. If we can't do random imputation saying that mode we got yes, so I'll be imputing with wherever you have any values with yes. It is absolutely wrong. Individual with that particular person doesn't have a TB, you can't say it is having a TB, right? So when you are dealing with the healthcare data, you should be extra careful while we are doing the imputation. But most of the time, we will be doing these imputation techniques as well only. That is mean, median, and the mode. So here we have so many extreme values, right? So when you observe this data, so many extreme values will be having. Extreme values in the sense, all are outliers. So when you are using the box plots, it is confirmed that whatever the values that are beyond this will be outliers only. When you have outliers, what kind of imputation techniques we will be using? We should go with the median instead of mean. Mean will definitely get affected with the outliers. That is the reason we won't be going with the mean. Instead, we will be going with the median imputation. So these are the things we will be doing when it comes to exploratory data analysis. What we will be doing in exploratory data analysis? We will be finding out mean, median, and mode. You can find out the mean, median, mode here as well. It is a first moment business decision. So we'll be finding out second moment business decision. We'll be finding out what is that variance. How far that values are spread from the mean. So here the box plot also will tell you whether you have symmetrical data or not, or whether it is right skew data or not. So you can see most of the data present in the left side, and right side data will be having extreme values. So it is a right skewed. It is not having any. It is not having the normal distribution. It is a variance. How far that values are present from the mean. So here we are taking median, right? That is 50%. That means average value, mean only. So how far data are present on the from the mean. So that we will be calling it as variance. And using this, we will be finding out the spread of the data, how data is spread. And then we will be finding out the skewness. Symmetry we have found out, right? Box plot using. Or you can go with the skewness as well, whether it is having positive skewness or negative skewness. Positive skewness means right side skewed, where it is negative skewness means left side skewed. Like that, we will be able to find out, and we will be doing the exploratory data analysis. When you do exploratory data analysis, you will come to know what are the features, what are the inferences we'll be having in that particular data, what are the inferences that are hidden in that particular data frame. So these are the things we will be doing when it comes to exploratory data analysis. And pre-processing, whatever the data will be having, where exactly we'll be having null values, duplicate values, these are the outliers. How we can eliminate those values, we will be doing in comes to pre-processing. So these are the things we will be doing, guys. There are so many other things. In this time, we can't able to cover all those things. If you want to, you can simply go through 360DigiTMG. YouTube channel. In that, all the data pre-processing techniques and various ML techniques, various deployment techniques, all will be there on YouTube channel. If you are interested, in that case, you can check it out. And if you are into the data science and you want to kickstart your career in the data science, in that case, you can start with Python. So those Python videos are available on 360 Tame Python by Bharani. You can simply go to YouTube and search Tame Python by Bharani. So all the Python sessions that are required for the data science videos are there in that YouTube channel for free. You can check it out. So that is it for today, guys. Tomorrow we will be coming up with one more session with unsupervised. We have discussed, right, what is unsupervised. Among these, we will be taking one algorithm, that is k-means clustering. K-means clustering, and we'll try to understand what exactly the k-means clustering is and what is the mathematics behind that particular algorithm, and how can we apply that k-means clustering in real time. I'll be taking one use case scenario and we'll try to understand the k-means in detail. That we will be doing in the next class. And thank you for joining, guys. And if you are interested, in that case, I hope you will join in the next session as well. And yeah, that's it for today, guys. And have a nice day. And we'll see you in the next session.